Okay, velocity time graphs. So this time we're looking at how velocity changes with time. What we need to do here is have a look at each one of these lines and describe what they're doing. So we'll start off with this black line at the bottom. This is showing that velocity is increasing. So this time, if we call this delta V and this delta T, we can have a look at the gradient, and that's going to equal delta V over delta T. That's an acceleration this time, a change in speed with time, change in velocity with time, and that is going to equal 10 minus 0 meters per second, and that's going to be divided by 5 minus 0 seconds, and that is equal to 10 over 5 meters per second squared, which is equal to 2 meters per second squared. Okay, so the gradient of a velocity time graph gives us the acceleration. Another thing that we can do with this time we can actually find the area underneath this graph, and this gives us a sensible unit when we do this. So if I know how to find the area of a triangle, it's half the base times the height. So if I do area under graph, is equal to, in this case, half delta T delta V, which is equal to half times 5 seconds times 10 meters per second, which is equal, in this case, to 25 meters. So that gives us the distance under the graph. If you can't see why this gives us a unit of distance, have a go at it yourself. Write out the units as fractions, multiply them together along with the numbers, and see if you can get meters out. If you can't do that, come and see me and I will show you how to do it. So, quick recap. The gradient of a VT graph gives us an acceleration. Find that out in the usual way, the change in y over the change in x. And the area under the graph in this case, because when we're multiplying these units together, we get a sensible unit of meters out. That gives us the distance travelled in that time, at that speed. So the only other things that we've got to look at, that was a positive gradient, the black line. The blue line is a negative gradient. So the black line gave us a positive acceleration, or an acceleration, and the blue line would give us a negative acceleration, or sometimes a deceleration. Okay, the red line, that's showing that V doesn't change, velocity doesn't change all the way through the time. That is a flat gradient, so the gradient calculation here will come out to 0, which means a constant speed or 0 acceleration. The green line gives us a changing gradient. So this means that the velocity is changing all the way along here. It's really bad physics teaching of me that, so we'll put constant velocity just in there. It means that the velocity is changing all the way along, but also the gradient of this graph. If you notice, as I move the ruler along a tangent to the curve, the steepness of the ruler changes, so the gradient of that graph is changing all the way along, so this is a changing acceleration. And that's pretty much all you've got to know for velocity time graphs.